Soap versus water. Remember how oil is insoluble in water, but table salt is soluble? Some molecules, like oil, are hydrophobic, meaning they have the property of being afraid of water. This has to do with how parts of atoms called electrons work, which you'll learn more about in high school chemistry. For now, consider that oil is hydrophobic. Other molecules, like sodium hydroxide, the lye we used to make soap, as well as sodium chloride, regular table salt, are hydrophilic. This means they have the property of loving water. Again, you'll learn more about why this is in high school chemistry. Molecules that are hydrophobic tend to bunch around each other when placed in water. This is why oil floats in a layer on water. Molecules that are hydrophilic like to interact with water molecules. This is why table salt dissolves easily in water. By replacing a hydrogen atom on the lauric acid with a sodium atom, we made part of the sodium laurate molecule hydrophilic. We sometimes call that part the head. However, the rest of the molecule, which we call the tail, stayed hydrophobic. When these molecules bunch together, they form spherical micelles. We can see these micelles. They're bubbles. In a micelle, the hydrophilic heads line up outward, while the hydrophobic tails point inward. The model below shows how this works. Turn to the next blank page in your notebook and write soap bubble formation model at the top of the page. Then draw a model of soap formation that shows the following: water molecules, soap molecules with hydrophilic heads and hydrophobic tails, hydrophilic heads interacting with water molecules, labels showing each component of the model.